Okay, so lesson 1.7 shifts the focus from dealing with angles and lines and segments and all those things to dealing with just lines and segments in the coordinate plane. So we're going to talk about the distance formula and the midpoint formula. And these are two formulas that we're going to use later on in class, so they're going to be something we come back to. So it's good to have a working understanding of both of these formulas. So the midpoint formula is described as the coordinate of the midpoint is the average or the mean of the coordinates of the endpoints. So to find the midpoint, just on a number line, is pretty simple. It's the average of the two coordinates. If the coordinates are a and b, you take a plus b, you divide that by 2. So it's pretty straightforward. It's just the average. Now, the midpoint in the coordinate plane is a little bit different because you have two different xy ordered pairs, all right? So we're finding the average of those two different pieces of the ordered pair. So the coordinates of the midpoint are the average of the x coordinates and the average of the y coordinates. So you're finding two averages. So the midpoint for this set of points, A and B, is going to be the average of the x values, and I'm going to use x1 and x2 divided by 2, and then the average of y1 and y2, the average of the y values. And that's a coordinate. So it's an ordered pair, parentheses on the outside, comma in the middle. So it's an ordered pair. The midpoint in a coordinate plane is an ordered pair. Midpoint on a number line is just a single value. So in example 1, finding the midpoint on a number line is fairly simple. The coordinates are -4 and +9. So it's just the average of -4 and +9. So I take -4 plus 9, divide that by 2. That becomes 5 divided by 2. And I would prefer, 2.5. All right. You could leave it as a fraction, a simplified fraction. I'd be okay with that. But getting it as a decimal is sometimes a little bit easier to work with. So it's up to you. I would give you instruction on whether I wanted you to use a decimal or fraction. But if I don't say, use whatever you're more comfortable with. For part B, it's a little more complex, but it's still not the worst thing in the world because we have x values, 7 and 2. So the midpoint, and this is going to be a little bit more writing, but the midpoint is the average of the x values, 7 and 2 are the x values, the average of those two, and the average of the y values, 5 and -4. The average of 5 and -4. And I divide that by 2 also. So the midpoint, m, and I'm going to use m, parentheses, 7 plus 2 divided by 2 is again 9 divided by 2, or not again, is 9 divided by 2, that's 4.5. 5 plus -4 is 1. 1 divided by 2 is a half, so 0.5. Again, up to you on whether you want to use a decimal or a fraction. If I'm graphing this, 2, 3, 4, and a half, so right here would be where that midpoint is. And that should make sense because it's halfway between the two points or the two ordered pairs on the coordinate grid. So really it's just finding averages for midpoint. It's not a real tough thing. You just have to pay attention to average of the x values, average of the y values. That's it. Midpoint is an average. All right, so example 2 can be a little confusing, finding the other endpoint. So in this example, you're given one endpoint, you're given the midpoint, you have to find the other endpoint. Now, I know there's a graph there, and you could just kind of count, but I do want to give you a definite way of finding the other endpoint algebraically. So the formula for midpoint, at least for the x value, if I'm trying to find the midpoint of, x, y, whatever that might be, the midpoint is equal to, remember we said x1 plus x2 divided by 2, y1 plus y2 divided by 2. So if I'm trying to find just the x value of the midpoint, or the end point, and I'm given the midpoint, the x value of the midpoint is -2. So that's this part of the equation, all right? And then the x value of one of the endpoints is -5. So -5 plus, and I'm just going to use x2 just to have another point. So we know one of the endpoints, we don't know the other endpoint. So to solve this equation, I've only got to do two things. I've got to multiply both sides by 2. So if I multiply both sides by 2, I get -4 equals -5 plus x2. And then to finish solving that, I'd add 5 to both sides. So x2 ends up being +1. Okay, and I know that was probably a little hard to follow at first, but it's understanding we're using the same formula for midpoint, but the big difference is we're not given one of the endpoints. We're given the midpoint and the other endpoint. So to find the y value, I'm going to use blue and I'm going to do the same process. Midpoint is 1. Midpoint y value is 1. One of the endpoints y value is 7. So the equation I set up is the midpoint 1 equals the value of that endpoint y value plus y2. Divided by 2. So to solve that, it's the same process. Multiply both sides by 2. 2 equals 7 plus y2. Y2. Subtract 7 from both sides. So y2 should be -5. And the good part of this is that I can test this. If I graph the point 1, -5, it should make some sense that it's the other endpoint. It's the same distance from the midpoint as the other endpoint. And that's the whole definition. Now again, I know you could probably think, oh, I could count that. But I think it's important for us to know how to do this algebraically in case you aren't given a graph. So these you'll get some practice on. This isn't going to be something you pick up right away. It's a process. It's understanding we're doing the same problem, we're just given different information. Now, what I consider the most, I'd say, maybe not difficult, but just hard to get down parts of this lesson is the distance formula, all right? The distance formula tells you how long a segment is when it's not just a segment on a number line that, we could just count, right? If I had points at, 4 and 6, I could just count and say 4, 5, 6, that's 2 units long. This is a little different. So you have 2 points. To find the distance between those 2 points on a coordinate plane, you take the square root of the difference of the x values squared and the difference of the y values squared. And it's very important that these are the same. You start with the same point and you subtract the values that are from the same point. So in example 3, it's really just us following this formula for right now. So the distance between these two, every time I'm going to make a big square root. I'm going to do x minus x. So for me, easiest thing for me is just to take -7 minus 4. -7 minus 4, square it. Okay, that's the x value subtracted. Now, if I do -7 minus 4, that means I have to do 5 minus -3. That order does matter. I could do this the other way around. I could have done 4 minus -7, but then I would have had to do -3 minus 5. I just like doing left to right. -7 minus 4, 5 minus -3. X's minus X's, Y's minus Y's. So to simplify this, and I'm going to try and do this a little bit more in a broken down way, -4 minus 7 is -11. And that parentheses is extremely important. 5 minus negative 3 is 8, positive 8. So this distance is going to be the square root of 121 plus 64, or the square root of 185. And I know that I said round to the nearest tenth. So this is a case where you're going to absolutely have to use your calculator to find this and then round it. So you're going to take 185, determine the square root of that. It's 13.60. So to the nearest tenth, that would be 13.6. Okay, and I know that seems like a lot of steps to get just a single number, but we will use the distance formula in a lot of different ways going forward this year. So right now, I just want you to understand how to use it. We're going to go more in depth as to how it works and why we need it. But right now, I just want you to pick up on how to basically apply the formula when it's shown to you. All right. For right now, I just want you guys to get used to plugging into this formula. That means you don't need to memorize it right now. You're going to have this formula available to you when we're doing checkpoints and things like that, because right now, memorizing it is not the goal. The goal is for you to be able to use it. Later on, you may have to memorize it, or you may have to know how to work with it and use some, I guess you could call them shortcuts. So if we're finding the distance between two towns on a grid like this, and I think I'll use yellow instead of green, Augusta and Brookline. Augusta is a nice point because it's 0, 0. Okay. Brookline is the point 8, 2. I just want you to recognize this grid is going up by 2s. So to find that distance, I'm going to take 0 minus 8 squared plus 0 minus 2 squared. X minus x, y minus y. So that distance is going to be the square root of negative 8 squared plus negative 2 squared. Again, the parentheses being extremely important. So that's going to be 64 plus 4, or 68. So if I'm going to do the square root of 68 and round it, square root of 68 is 8.24. I would round that to just 8.2. Okay, 8.2, and in this case, I'm just going to use the word units. Now this, it might be miles, it might be something else, but for context problems like this, where I actually give you towns, names of towns, it's good to use units. It's good to have an idea of, well, kilometers, miles. Just using those units when it's not an abstract problem like before, where I just kind of threw numbers at you. So for Brookline and Davenport, Brookline, we already know the coordinates. Davenport is up here. Davenport's kind of between 4 and 6, so I would say the x value is 5 and the y value is 10. So this is a good chance for you to try this. I want you to wait. I want you to stop and pause the video, work through this. When you resume the video, I'll flash my answers on the screen. You can compare with me. Then you move on to the practice straight from this. All right.